the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No mic, no fame, just the sound we crave. Tune and turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just a vibe that's real. Faceless words you can touch and feel. In shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go.
His research focused extensively on vision, including color vision, binocular perception, eye movements, and hyperacuity. In 1892, he proposed the opponent color theory, which posited that color vision is based on three opponent channels: red versus green, blue versus yellow, and black versus white. This theory challenged the prevailing trichromatic theory of Young, Maxwell, and Helmholtz. Thanks for reading No Mic Podcast Scribed by Facelesslingjutsu. Subscribe for free to receive new posts and support my work. Karl Ewald Konstantin Hering was born on August 5, 1834, in Altgersdorf, a small village in Saxony, Germany. He was the son of a Lutheran pastor, and it is believed his family was relatively poor. He attended gymnasium in Zittau, a secondary school, before enrolling at the University of Leipzig in 1853. At Leipzig, Hering pursued a broad range of studies, including philosophy, zoology, and medicine. He was influenced by the work of E. H. Weber, known for Weber's law in psychophysics, and Gustav Theodor Fechner, considered the founder of psychophysics. Although there's no direct evidence he formally studied under them, Hering later proudly acknowledged himself as a student of Fechner. He completed his MD degree in 1860. After graduating, Hering did not immediately embark on an academic career. Instead, he practiced as a physician in Leipzig for 5 years. Despite having limited time and financial resources, he dedicated himself to research, particularly in the field of vision. During this period, between 1861 and 1864, he published a series of 5 papers titled Contributions to Physiology, in which he explored binocular vision and the complex problem of the horopter, the theoretical curve in space where points project onto corresponding retinal locations in both eyes. In a remarkable display of independent scientific prowess, Hering, as a relatively unknown scientist, published his own mathematical derivation of the horopter. This was a significant achievement, as it paralleled the work of Hermann von Helmholtz, who was already a highly respected and established German scientist. Hering even went so far as to point out minor mathematical errors in Helmholtz's derivation, setting the stage for a lifelong scientific rivalry that would characterize much of their careers. Their disagreements were not only scientific but also philosophical, with Hering being a nativist believing in innate spatial perceptions and Helmholtz an empiricist emphasizing learned experience. Working alongside Joseph Breuer, who would later become famous for his collaborative work with Sigmund Freud on the origins of hysteria, Hering investigated the mechanisms of respiration. Their findings, published in 1868, described a crucial self-regulatory reflex in breathing. They demonstrated that sustained inflation of the lungs, for instance, triggers a reflex that inhibits further inspiration and promotes exhalation, effectively preventing overinflation of the lungs. This reflex is mediated by stretch receptors in the airways, which send signals via the vagus nerve to the brainstem. The Hering-Breuer reflex provided a fundamental insight into the neural control of breathing and remains a cornerstone of respiratory physiology, appearing in virtually every textbook on the subject. Concurrent with and extending beyond his respiratory research, Hering continued his prolific work on vision, leading to his highly influential opponent color theory. While the theory itself was fully articulated and published later, particularly in his 1892 work, the foundational ideas and experimental observations that led to it were developed throughout his career, particularly during his time as a professor in Vienna and Prague. Hering's opponent color theory directly challenged the prevailing young Helmholtz trichromatic theory, which proposed that color vision was based on three primary colors: red, green, and blue, detected by separate cone receptors in the retina. Hering, through meticulous psychophysical experiments and observations of phenomena like afterimages, argued that color perception is organized into opposing pairs: red-green, blue-yellow, and black-white. He observed that humans never perceive reddish-green or yellowish-blue, suggesting that these color pairs are antagonistic. His opponent color theory, though initially met with resistance due to its divergence from the dominant young Helmholtz view, gained significant traction over time. Modern understanding of color vision now largely reconciles both theories, viewing the trichromatic theory as explaining events at the photoreceptor level cones and Hering's opponent process theory as describing how signals are processed further up the visual pathway, particularly in the retina and lateral geniculate nucleus LGN of the thalamus, where neurons respond antagonistically to these color pairs. The Hering-Breuer reflex, and the opponent color theory, Ewald Hering continued to make significant contributions to the understanding of visual perception, particularly in the areas of eye movements and hyperacuity. These later investigations further solidified his reputation as a pioneering figure in experimental psychology and physiology. In 1879, Hering published a comprehensive review on eye movements and the spatial sense for Ludimar Hermann's Handbuch der Physiologie, Handbook of Physiology. This work not only provided a detailed overview of existing knowledge but also introduced his own groundbreaking observations and theories. Crucially, Hering developed a novel, if somewhat unusual, method for recording eye movements by listening to the muscle sounds produced during their rapid movements. He described clapping sounds that could be heard by placing a device similar to a stethoscope on the eyelid, and noted their correlation with the perceived movement of afterimages or floaters in the eye. He applied this technique to study eye movements during reading, identifying the rapid, jerky movements he termed ruck jerks, which we now know as saccades. This was some of the earliest experimental evidence of discontinuous eye movements outside of reflex actions. This work on eye movements also led to his articulation of Hering's law of equal innervation. This law posits that the innervation nerve impulses sent to the muscles of both eyes is always equal in intensity, even if the eyes are moving in opposite directions as invergence movements. This explained why the eyes typically move in a conjugate fashion, i.e. together, and how vergence movements, where the eyes move inward or outward to focus on objects at different depths, are also precisely coordinated. While modern research has refined our understanding of the neural control of eye movements, Hering's law laid a foundational principle for understanding their coordinated nature. Towards the end of the 19th century, Hering delved into the remarkable phenomenon of hyperacuity, specifically addressed in his 1899 treatise on the limits of visual acuity. Hyperacuity refers to the ability of the visual system to detect spatial differences that are significantly smaller than the spacing of individual photoreceptors in the retina. A classic example is vernier acuity, the ability to detect a misalignment of two lines that are perfectly straight. Hering recognized that humans could perceive such subtle misalignments with a precision that seemed to defy the anatomical limits imposed by the size of individual cone receptors. Hering proposed an explanation for hyperacuity that involved a process of neural averaging. He suggested that incessant eye movements, the very saccades he had previously studied, caused the image of a stimulus to sweep across multiple retinal receptors. The nervous system then effectively averaged the signals from these various receptors, allowing for a much finer spatial resolution than what would be possible from the response of a single receptor. One of Ewald Hering's most significant and enduring later works, which served as a culmination of his lifelong research on color vision and perception, was his magnum opus, Grundzüge der Lehre vom Lichtsein, Outlines of a Theory of the Light Sense. While aspects of his opponent color theory had been published earlier, this comprehensive treatise, which appeared in 1905 and was later translated into English in 1964, represented his most complete and systematic exposition of his ideas on how the visual system processes light and color. In this work, Hering meticulously laid out his opponent process theory in full detail, contrasting it explicitly with the young Helmholtz trichromatic theory. He argued that the perception of color was not simply a matter of the additive mixing of three primary lights, but rather involved antagonistic physiological processes. He proposed the existence of three pairs of opponent processes: red-green rot-grün. This system registers either red or green, but never a mixture of the two. Blue-yellow blau-gelb. Similarly, this system registers either blue or yellow, but not a blend. Black-white schwarz-weiß. This achromatic system registers lightness and darkness. Ewald Hering's illustrious career came to an end with his death on January 26, 1918, in Leipzig, Germany, at the age of 83. He passed away amidst the turbulent final year of World War I, a period of immense global upheaval. References: Ernst Mach, Stanford Encyclopedia of Philosophy. May 21, 2008. Retrieved September 4, 2012. Hering and Mach were atheists, and disbelieved in a soul, but still accepted the idea that nature had internal direction. Hering, Ewald 1868. Die Lehre vom Binocularem sehen. Leipzig. Hering, Ewald 1977. The Theory of Binocular Vision, Ewald Hering 1868, edited by Bruce Bridgman and Lawrence Stark, translation and introduction by Bruce Bridgman, commentary by Lawrence Stark. New York, Plenum Press. ISBN 978-0306310164. Smith, A. Mark 2001. Al-Hassan's Theory of Visual Perception. Volume 2, English translation. Philadelphia, American Philosophical Society. Wells, W.C. 1792. An Essay upon Single Vision with Two Eyes, together with experiments and observations on several other subjects in optics. London, Cadell. Strasburger, Hans, Huber, Jürg, Rose, David 2018. Ewald Hering 1899 on the Limits of Visual Acuity, a Translation and Commentary. With a supplement on Alfred Volkmann 1863 Physiological Investigations in the Field of Optics. Eye Perception. 93-2041669518763667. doi 10.11772041669518763665, PMC 599-0881, PMID 298999967. Following G. Westheimer. Westheimer, Gerald 1975. Visual Acuity and Hyperacuity. Investigative Ophthalmology and Visual Science. 14.8, 570-572. PMID 115-0397. Link to Westheimer 1975. Strasburger, Hans, Rose, David 2018. Alfred Volkmann 1863. Physiological Investigations in the Field of Optics Physiologische Untersuchungen im Gebiet der Optik. Partial Translation and Commentary, Supplement to Strasburger, H. Huber, J. Rose, D. 2018. Ewald Herring 1899 on the Limits of Visual Acuity. Eye Perception. 93-20416695187637. doi 10.11772041669518763665. PMC 599-0881. PMID 298999967. Volkmann, Alfred 1863. Physiological Investigations in the Field of Optics Physiologische Untersuchungen im Gebiet der Optik. Leipzig, Breitkopf und Hartel. Wolfing, Ernst Anton 1892. Über den kleinsten Gesichtswinkel on the smallest visual angle. Zeitschrift für Biology. Neue Folge. 11, 199-202. In the year 1892, Wolfing showed that one can recognize differences in position that correspond to a visual angle of 12 to 10 or even less. Translated from Herring 1899, Westheimer, Gerald 2018. Herring Hermeneutics, Supplement to Translation and Commentary of Herring 1899 by Strasburger et al. Eye Perception. 96-2041669518881592. doi 10.11772041669518881591. PMC 629-1878. PMID 30559959. Jung, H. Cotteris, Ann Golden, J. Brainerd, D. Farrell, J. E. Wandel, B.A. 2017. Simulating Retinal Encoding, Factors Influencing Vernier Acuity. Human Vision and Electronic Imaging. 2017-14, 177-181. doi 10.2352 ISSN.2470-1173.2017.14.HVEI 140. Rucci, M. Levin, R. Poletti, M. Santini, F. 2007. Miniature Eye Movements Enhance Fine Spatial Detail PDF. Nature. 447 7146, 851-854. Bibcode 2007 Nature.447.852R. doi 10.1038 Nature 05866. PMID 175687745. S2 SID 441, 6740. Turner, R.M. 1994. In the Eye's Mind, Vision and the Helmholtz-Herring Controversy. Princeton, N.J., Princeton University Press. ISBN 978-0-691-03397-6. Moore, Walter John May 29, 1992, Schrödinger, Life and Thought, Cambridge University Press, ISBN 9780521437677. Stanley, Finger. 1994. Origins of Neuroscience, A History of Explorations into Brain Function. Oxford University Press. p. 338. ISBN 978-0-262-01704-6. Further reading. Bauman C. June 1992. Ewald Hering's Opponent Colors. History of an Idea. Der Ophthalmologe, Zeitschrift der Deutschen Ophthalmologischen Gesellschaft in German. 89-3, 249-52. ISSN 0941-293X. PMID 130-3712. Yanko J. 1995. Mach and Hering's Physiology of the Senses. Clio Medica. Volume 33. Pages 89-96. PMID 906-1228. Otis, Laura 1994. Organic Memory, History and the Body in the Late 19th and Early 20th Centuries. Lincoln, University of Nebraska Press. ISBN 0-80323561-5. OCLC 29638386. Turner Ars 1993. Vision Studies in Germany, Helmholtz vs. Hering. Osiris. 81, 80-103. doi 10.1086 368719. PMID 11639585. S2 SID 429401220. Singh, Iona 2012. Visual Syntax, chapter from the book, Color, Facture, Art and Design. Hampshire, UK 0 Books. Pages 65-82. ISBN 978-1-78099-629-5.
Mics on the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark, unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No light, no fame, just the sound we crave. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Hidden in shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go. Pure and raw. Pure and raw. feel. Pure and raw. Day.